Hello everybody, welcome back to another video of me learning the Zig programming language. And the goal is to take our time, understand the programming language, learn its primitives, and the idiomatic way of doing things in Zig. And the end goal isn't really just to learn Zig, but to understand and maybe get better at writing systems programs. And Zig is a pathway that I've chosen to get closer to that goal. Cool. If it's their first time here, I'm using this wonderful list of exercises, or essentially a course, to learn and understand Zig better. It's made by Chris Bosch. A huge shout out to him for putting all of this together. Let me refresh that. I'm not sure what's happening here. Never mind. But essentially, it's hosted on Codebug. I think there's a mirror on GitHub, but all it does is point to Codebug, and there's a bunch of exercises. I've already have a copy of this, so we can dive into the code and get started. Cool. So here are I should probably commit them, but never mind. We have been through around 48 exercises. I'm not sure what happened to exercise number 49 here, but let me see. Did I accidentally delete it? Oh yeah, it's a quiz that looks like I might have just deleted that by mistake. Never mind. So I have completed 49 exercises. The previous one I do remember. It's about methods, which is a function encapsulated by a struct or an enum. And that was a good foray into around the object-oriented space. I don't Zig isn't really an object-oriented language, but um, that is something that I found interesting because a lot of my previous experiences has been in C Sharp, Java, and heavily object-oriented languages. But yeah, I believe we already completed the quiz. Let's go on to the next exercise, exercise number 50. We're with a total of 115 exercises. We're inching close to the halfway mark. That's really, really fun. But we're not there yet. We haven't fully learned the language, but we're getting closer and closer to understand the fundamentals of what we need to jump ahead. Cool. Let's seems like a poem. Let me read it. We live on a placid island of ignorance in the mists of the black seas of infinity, and it was not meant that we should voyage far. We live on a placid island of ignorance in the midst of black seas of infinity, and it was not meant that we should voyage far. The call of I did not know how to pronounce this. To by H.P. Lovecraft. I will look this up. Um, Let me see. I will not even attempt to pronounce it incorrectly on YouTube. Let's see if I can search it. How do you pronounce whatever this? Cthulhu. Perfect. I like this kind of explanations over like the phonetic spellings. Cthulhu. Cthulhu. Okay. I will have to look up the poem. I do like poetry quite a bit. Cool. Cthulhu. Cthulhu. The Call of Cthulhu. Oh, I don't think I shared the other screen, but I actually looked it up on Google to see how do you pronounce that, and it says Cthulhu. Okay, that's fun. Let's get back to it. Zig has at least 4 ways of expressing no value. Undefined. Yep, we saw this. Undefined should not be thought of as a value, but as a way of telling the compiler you are not assigning a value yet. Any variable may be set undefined, but attempting to read its value before assigning one is always a mistake. Would the compiler blow up, or would it just go ahead and print something? What does this mean? But attempting to read its value is always a mistake. Yeah, but is that from the perspective of the compiler or from us, like logically thinking? I want to test that out. Actually, no, I'm not going to go on a tangent. Let's see what the exercise is about. Cool. Null. Null primitive is that a value means no value. Okay. Undefined value does not exist. It will be assigned at some point in the future. Null is that there is no value. This is typically used with optional types as optional U8 shown above. When the variable equals null, that's not a value of type U8. It means that you've assigned for weight to no value. Cool. Error. Error union we have here. There's a type bad error. Errors are very similar to nulls. They are a value, but they usually indicate that the real value you are looking for does not exist. Instead of no value, you have an error. The example error union of my error U8 mean that foo either holds a U8 value or a my error. Cool. That makes sense. That's why it's called an error union. Combination of two types. Fine. Void. Void is a type, not a value. It is the most popular of the 0-bit types, those which take up absolutely no space and have only a semantic value. Okay, makes sense, straightforward. When compiled to an executable code, 0-bit types generate no code at all. Ah, I see, okay. The above example shows a variable foo of type void which is assigned the value of an empty expression. Example shows a variable of type void which is assigned the value of an empty expression. Okay, makes sense. It is much more common to see void as the return type of function that returns nothing. Okay, so just an expression, makes sense. Because all these types of different types as different ways, as these ways of expressing different types of no value, because they each serve a purpose. Undefined is there's no value yet. This cannot be read yet. Null, there is no explicit value of no value. It is an explicit value indicating there is no value here. Errors, there is no value because something went wrong. Void, there will never be a new value here. Makes sense. It's nice that it's compared and contrasted here in a single line. Makes it easier to wrap one's head around what's happening. Cool. Please use the correct no value for each. Okay. Replace the 3 question marks with the right no value semantics to make this program print out the cursed quote from Necronomicon, if you dare. Cool. We have the standard library, we have the error type, say public function main. First line, there's a constant pointer 16 items of unsigned integers of 8 bits, which can also represent characters, and this represents string. First line, we're assigning a value. So we know that initially there was nothing, and then we are assigning. So null would not work because Zig needs a nullable type here, right? Optional type. So what else? Undefined would be appropriate here because we're saying at this point in time, we don't have anything for it. But eventually we will give it a value. Cool. Now let's look at the second line. Error. It can either be an error or a constant pointer of 21 characters. Same thing here. Initially, I will say it is This is the tricky part. Undefined might work here. Maybe null will also work there. We'll play around a bit later. I'll go with the value I think is correct at this point. We'll see. And we're printing something here, and we're printing another line. Right off the bat, I know there's nothing being returned in this function. So the return type is void. Zero semantic. Okay. Uh, we have something here. We have a pointer possibility here. So instead of undefined, I'm going to say, hey, this can be null. The thing is, I know this program's going to execute, but I hope I got it right. Let me see. Oh, oh, that compiles. This is not dead. That is not dead, which can eternal lie, and with strange eons, even life, even death may die. I need to look up this poem. Um, I like it. I like that the exercises teaches programming by sprinkling in some fun literature. Cool. A lot of character to it. But I think we understand the gist from this exercise. We're going through the different no value types. We have optionals. We have. I also want to see what happens if it's null. I believe it should just immediately the compiler should immediately shout and say, "Hey, what are you? How are you assigning null?" Um, yeah, when it's not an optional type exactly. Cool. I think we got it. Let's go on to the next exercise. The first one represented no values. The next one is going to represent values. Now, if you thought the last exercise was a deep dive, hold on to your hat because we're about to descend into the computer's molten core. Shouting. Down here, the bits and the bytes flow from RAM to the CPU like a hot, dense fluid. Forces are incredible, but how does all of this relate to the data in our Zig programs? Let's head back up to the text editor and find out. I believe if this was a video, actually, I like that it's a text in firstly, but I can imagine a character actor um, saying these words with precision. Cool. That's better. Now we can look at some familiar Zig code. Import adds the imported code to your own. In this case, code from the standard library is added to your program and compiled with it. All of this will be loaded into the RAM when it runs. Oh, and the thing that we name const standard, that's a struct. Ah, okay. It is a structure type. It says it's a type, but I believe it's user structs are user defined types. Let's go in here. This whole thing gets loaded into our memory, I believe. Will be compiled as part of the program. And this is a structure. Is that right? Okay, good. I was very curious. That is good. Remember our old RPG character struct? A struct is really just a convenient way to deal with memory. These fields are values of a particular size. Add them together and you have the size of the struct as a whole. That makes perfect sense. Size of this plus this plus this. Here we create a character called the narrator that is a constant immutable instance of the character struct. It is stored in your program as data, and like the instruction code, it is loaded into the RAM when your program runs. The relative location of this data in memory is hard coded, and neither the address nor the value can change. Okay, because it's a constant struct. And I thought we could reassign each of these values. Actually, we cannot because it's a constant. That makes sense. The global wizard character is very similar. The address of the data won't change, but the data itself can change since it's a variable type and not a constant. Makes sense. Now, a function is is instruction code at a particular address. Oh, interesting way of putting it. Usually, when you hear the word function, it's like it's a named collection for a set of code, or it is a set of logically relevant um, statements that are grouped together under a single name. But I like this explanation, a very low level thinking. A function is an instruction code at a particular address. The address part is very interesting. Function parameters in Zig are always immutable. Okay, so whatever is passed in, it's immutable, makes perfect sense, unless we pass it by reference. Uh, they are stored in the stack. A stack is a type of data structure, and the stack is a specific bit. It's a specific bit. Let's see, specific bit of RAM reserved for your program. Okay. The CPU has special support for adding and removing things from the stack, so it is an extremely efficient place for memory storage. Also, when a function executes, the input arguments are often loaded into the beating heart of the CPU itself in registers. Yes, I believe I remember that. When a function executes, the input arguments are often loaded onto the beating heart of the CPU itself in its registers. Our main function here has no input parameters, but it will have a stack entry called a frame. Oh, it is a frame. Okay, cool. Now here the glorp character will be allocated on the stack because each instance of glorp is mutable and therefore unique to the allocation of to this function. Okay, makes sense. So this is loaded onto the stack. The reward XP value is interesting. It's an immutable value, so even though it's local, it can be put into the global data and shared across invocations. But being such a small value, it may also be inclined as a literal value in the instruction code where it is used. It's up to the compiler. Ah, okay. I see we want to precisely specify things, but in certain instances, I did not realize we also let the compiler decide where something goes. I believe I understand what they mean by this. They're saying, hey, this is constant. It's enclosed within the main function. So main is put onto the stack. Now XP here might just be in line with the instructions, or it can be put in the global data and shared across all invocations of this function. Okay. Cool. And let's circle back to that standard struct we imported at the top. Since it's just a regular Zig value, once it's imported, we can also assign new names for its fields and declarations. Debug refers to an other struct, and print is a public function namespace with that structure. That's another Zig value. Once it's imported, we can also assign a new name for its fields and declarations. Debug refers to another struct, and print is a public function mapped. Okay, I see what's happening. We're not really modifying the memory address or the value in the memory address. We're just on, can I say it's aliasing pretty much? New name, yeah. Standard debug struct, print struct. Can we do this? Oh, function. Oh, instead of, we could have passed in values here, I guess. Curious, can we do this too? But in this case, it'll be like invoking the function. Yeah, so it's void. What we need here is to assign the function itself, alias it, so we can call print wherever we want. Cool, okay, I understand it. Now let's look at assigning and pointing to values in Zig. So I wonder if all we need is print, we can just import print instead of everything else, or import debug and then use print instead of importing standard library directly. I'm not sure if that works. We'll try it out later. Now let's look at assigning and pointing to values in Zig. Um, we'll try the three different ways of making a new name to access our glop character and change one of its values. Now, glorp access 1 is incorrectly named. We ask Zig to set aside memory for another character struct. So we will assign glorp to glorp access 1 here. We're actually assigning all of the fields to make a copy. Okay, glorp access 1 is incorrectly named. We ask Zig to set aside memory for another character struct. So when we assign glorp to glorp access 1, we're actually assigning all the feeds to make a copy. Now we have two separate characters. Yes, I believe since structs across languages are a value type, copying them, assigning one to another means a copy is made. Now you don't need to fix this, but notice what gets printed in your program's output for this one compared to two assignments below. So we have glorp will get reassigned. Glorp access 1's gold is modified. Glorp's initial gold will remain the same. So when we say is it equal, 1 is to whatever. I think false will be printed here, right? Let me just run this. It's an error somewhere else. Cool. Let's fix the error and then we'll figure this out. Or another thing I can do, I guess. Yeah, we can also do that. We'll close that. Comment the rest out. What is this crying for? Okay. Cool. We'll undo that later. And just comment out the rest of the code because we can go one step at a time. Yep. 1 is not equal. First one is false. Obviously, because when we did this assignment here, glorp access 1 had a complete copy of glorp. Wasn't a reference to it. Let me undo all the changes I just made. Cool. Let's keep going. Now, if you try to do this with a const character instead of a var, changing the gold would give a compile error because const values are immutable. That's right. Now, if this was const, it would fail. This would fail because, again, when we say const it refers to one particular address in memory. Now, we do not want that const to be transformed and mutated in another way through a var. It makes no sense. The constant values cannot be put into variables. I believe that's what it's saying. We've seen that thing before too. Yep. Oh, we have example right here. Cool. Points to the original globs address. Also remember that we get one implicit dereference with struct fields. So accessing goal field from glorp access 2 looks just like accessing it from glorp. We get one implicit dereference. One access, one implicit dereference. Yep, makes sense. Okay. This is a side. This is an aside. Actually, there's no example for the aside, so this is a good time where we can write our own example. I'll keep this short but let's do this. Let me try whether I can directly just call the debug, um, import debug instead of importing the standard library. Maybe I can't do it because it's not exported. I just want to run it and see what happens. Zig run test. Root source file struct test has no. Okay, it's screaming that there's no main function. Public function main returns void. That actually compiled, but would it only throw an error when I use it? Debug dot print. I'll pass in this, I guess. Yeah, it only errors when you use it. No module name debug available within module test. Cool, we have to get it from the standard library, and then I can assign it. Say, I'd rather not alias it, honestly. I'd rather keep it verbose. I don't really want to alias print function like that. It's just confusing long term. Standard.debug.print. Hello. Can I just ignore this? Do we really have to pass that empty anonymous whatever type each time? Yeah, I wish the LSP would catch it and say, hey, you need to do that, but that's fine. Oh, accidentally click somewhere. Okay. Sig run test.sig. Cool. Hello is printing. Cool. Now let's write some more code. We'll say pub function. Never mind, I don't want another function right now. What I want here is a struct. Let me create the type. Const animal. This will be a type. So I can say struct. I will say name. Would it be an integer of 8? I will say what if I don't want to specify the size right now? I don't know if you saw that, but let's say 50 characters maximum, right? That's its name. What else would I have with it? Color of the animal, I guess. We'll do another one. 50. Shouldn't be that long, but whatever, I'll put 25 characters. We have a type. And now I'll create a bird. I'll say a constant bird of type animal. Color is red. Name is birdie. And we'll say const bird. We'll make this a variable. Bird buddy underscore. I believe that's the convention. Like animal. Oh, never mind. We're gonna pass it bird. And let me just print bird one. when the arguments will pass in and bird dot color. I'll copy that over, and for bird to bird body, we'll say I make this multi-line. Would Zig allow that? Oh, something's wrong here. I'm saying found equals expected equals found. Wait, what? I'm seeing a dot here. Is that why it's screaming? Wonder what that even does. I actually want to look into it. Local variable is never mutated. Fine. Mutated. Blue. Aren't we changing its properties? Hmm. Change the wrong one. And this is going to error out, right? Yep, it errors out because this is a constant type. I am super curious of something. I'll still be a constant pointer even if I use pointers. This isn't C. I'm gonna, okay, if I do a variable, this is gonna run. Expected 25 U8, found const 38 U8. So do we have to specify it each time? That doesn't make much sense. Fine, for now, I'll think about that a little later. We'll circle back to that. I'm just curious. Bird dot color is equal to. It's saying it's expecting an array of 38, but it found a constant pointer. Did we ever look into this? Why strings were defined this way? Let me switch over to the browser. Let's go to the documentation. Let's look at string. It's a slide now. Slices should be something else, right? Oh, I said string. Oh, it is slices. We haven't come to this portion yet. Essentially, okay, I'm gonna hold off on that. I'm very curious to get to know that more, but I believe in all the previous examples we had hard coded it to say, oh, the input will only be of that particular size. Um, We ended up using constant pointers. I'm going to slightly modify my function for now because I don't want to go off on a wild tangent. Let's just make these integers. Yeah, I'll say limbs, unsigned integers of 8 bits limbs. But I say legs, let me say legs. Oh. Bird, body. Why is it not airing out right off the bat? I'm gonna try this again. This isn't really a course. It's me trying to learn it. So yeah, I'm fine. I'm fine with it not being the most polished video. What's the point if I don't even try something? But like, let me just run this, see if we've run into some errors and fix them. Cool, it just worked off the bat. So we have, so what was the goal? The goal is to see how a constant, is to see if Zig compiler prevents the constant structure from being assigned to, from being copied over to a variable structure. So what I'll do is I'll create const, and we know this will blow up, and I'll remove that line and see if this will work. Cool, cannot assign to a constant. I'll remove that. What happens now? It worked. We can copy it over. What if it was a pointer now? That's right. I'm gonna say this is a reference, therefore a pointer. Now this is a variable pointer to bird. It has to throw an exception here. That makes sense previously why it wasn't, because if you're going to copy over, who cares what you're copying over? The reference is where it matters, right? Yeah, because if you think about assigning 2 to something, this is also a constant value, but it can be assigned to a variable. I think this will break. Um, yes, cannot assign to a constant, because bird buddy is now pointing to bird. So we cannot, again, we've seen this in a previous example with pointers. We cannot use a loophole to go and modify a pointer by just assigning the memory to some other variable. That doesn't make sense. It's wrong. It's illegal. And I believe I have an understanding of this better now. But something else that I want to look into more is strings and how a variable and strings are defined. I believe we can set it as a just just for a quick side note. I'm going to try something just for my curiosity. We're going to say variable s, and let's say abc. See this here. It's a constant length. You wait. We'll learn more about slices, but the previous one would have worked if I had used this. Let's just use it. Why leave it up to the air like that and sit and pretend like we know something when we don't? I'll say it's a constant. I'll say it has to be 5 characters. I don't know what this is. It's some slice thing, and we'll say unsigned integer of 8 bits, right? Needs to be at least, actually, let me just make color. Color, name would be fine. Let me remove this and I'll say, what happens now if I try to access color? Will it print some gibberish? because nothing was assigned, or it's just going to blow up and say, hey, we are forced to assign name when you are creating it. Name bird buddy dot name. Nice. Missing the name. Yeah, that makes sense. I'll say the name is 5 characters, right? Birdie. Run it. Cannot assign to a constant bird buddy. Yeah, that makes sense. Let me make this a variable. Okay, make this constant. Bird braid or legs cannot wait. Ah, I'll make this not a pointer anymore. Cannot. Yeah, this is what I was curious. Cannot format a slice without a specifier. Cool. We'll come back to it. We'll come back to slices, but I think the concept of pointers, not a constant pointer not being assigned to a variable pointer makes sense. That's the only thing I was trying to grasp, but we'll come back to strings. I am sure. I mean, it's right next. The next example is slices, so we can hold off a little bit and be patient. Cool. Now let's take a look at this thing. Glob2 will do what we want. It points to the original glob's address. Also remember that we get one implicit dereference. Cool. Now this is a variable here. We're taking a glorp, which is coming from here, which is variable. Good. Now we can access its goal. What it's screaming about here. Not really sure why it's screaming. It seems like correct syntax. I'm just gonna run this and see what it's screaming about. Glorp access to dot gold expected. Use var cons to declare variables. We're not declaring it, we're accessing the value held by this memory location, and we're gonna say dot gold. Yep, that is correct. What if I remove this with an error on the next line? Okay, there's something else here that's happened. Let me undo a few things. When I was putting a, oh yeah, that's right. That's why it's breaking. That works. That should work, and this will yield a true, I'm sure. Just there's an error down there, but this will work. We know. We'll circle back to it. The glorp access 3 is interesting. It's also a pointer, but it's a const pointer. Wouldn't that disallow changing the gold value? No. As you may recall from our earlier pointers, a constant pointer can't change what it's pointing at, but the value at the address it points to is still mutatable, so we can change it. Perfect sense. We already experimented the first half of this. The second half is that it's a variable here. We have a constant pointer here. Now, when we assign the address of this variable to the constant pointer, it means that the constant pointer always refers to that variable, which means the pointer has the ability to change the value held in the variable because it is a variable type. Makes sense. This is a good example. I understand this, but before we run it, we'll have to fix whatever errors was at the bottom. We'll go through that. Cool. Now, if we try to do this with a constant character pointer, that would not work and we would get a compiler error because the value becomes immutable. We ran into something like this too because constant character pointers are immutable. We'll circle back. It takes a number of passes to be fluent in a language. The initial thing, the beginner's luck plays in when we speed run through stuff, and then it's like the last 20% takes the most amount of time. Moving along, when arguments are passed to a function, they're always passed as constants, regardless of how they're declared in the calling function. So arg is a constant, bar is a constant. Knowing this, see if you can make level up work as expected. It should add the specified format to the supplied characters experience points. Now, before we can't even test it when there's an error somewhere deep down. Like, let me go fix that first. Line 174. Oh, it is this one. Okay, cool. The error is cannot assign to a constant. It should add the specified amount to the supplied characters experience points. I mean, in which case, make it a pointer, right? Or pass in the address of Clark. And we can still we can either do we don't have to dereference directly because it's a struct pointers, we can directly call it. Let me run this. Would this work? Perfect, it works. And number 2 and 3, which were the different kinds of pointer interactions and how they change, we know those are true, which is good. Let's see, previously the XP was 0 and after adding it, it became 200. Perfect, now we got it to work. And there's more. Data segments allocated at compile time and the stack allocated at runtime. Let me understand this. Data segments are allocated at compile time. Stack itself is allocated at runtime. Okay. I don't know why I always thought stack was compile time. And like the heap was runtime. Maybe stack is fixed size and heap is dynamic. Okay, cool. I need a refresh on my understanding of computer organization. It's been a while. No, aren't the only places where program data can be stored in memory. They're just the most efficient. Okay. Sometimes we don't know how much memory a program will need until the program is running. Also, there's a limit to the size of the stack allocated to the program, often set up by the operating system. For these occasions, we have the heap. Cool. Okay. Yes. You can heap as much heap memory as you like within the physical limitation, but it's much less efficient to manage with there's no built-in CPU support for adding and removing items we have with the stack. Okay. Heap is less efficient, stack super efficient. Uh, Also, depending on the type of the allocation, your program may have to do expensive work to manage the use of heap memory. We'll learn about heap allocators later. Depending on the type of allocation, your program may have to do expensive work. Cool. That is quite a bit of information. We'll be pleased to know that the next exercise gets you back to learning Zig features. We can use the right way to do more things. Cool. Now, this is interesting. A good read. It's much less efficient to manage because there's no built-in CPU support panel removing. Depending on the type of allocation, your program may have to do expensive work to manage the use of heap memory. We'll learn about heap allocators later. Cool. That is something that we do want to learn, something that I do find interesting, but yeah, I think this is a good place to call the video, even though we got to do only 2 exercises. These were really informative exercises. Good to run, and I'm starting to like me branching off and doing some asides or like fun little test programs. I think they're a good learning exercise. But yeah, I'll stop the video there. Another wonderful day of learning Zig. Um, Again, shout out to the folks over at Ziglang, doing this great work. As well as a huge shout out to Chris Bosch and the other open source guys coming in and putting exercises so that folks like me can speed run the language because they're doing all the hard work to teach us. Um, that'll be all. I think we can call it there. It's been a fun run learning about Zig. We've done 50, 51 exercises so far. Very small number, to be honest. The language is extremely vast. But I remember the creator of C++ at one point saying the goal should never be to learn the entirety of the language to in its depth. It should be about learning well the few things that you need to start building and then picking things up as you go about. That's sort of my approach. I want to understand the fundamentals of Zig, get a good grasp on the different areas, but the true goal has always been being a systems programmer, learning the systems way of thinking. And that means we need to take asides from Zig, go into computer organization, like in case of like big endian, little endian, refresh our memory, understand it, and things like that. I'm more than happy to do. But regardless, Zig has been really, really lovely. And I think um, Andrew Kelly, I believe, and the other people going. Again, I had heard about Zig from a couple of YouTubers like the Primogen, but um, knowing that one of Andrew Kelly's interview with the JetBrains YouTube channel, I think that it just finally got me to say, hey, go ahead, learn this thing. I really like the way they communicate. They're out there every day in the community, explaining their viewpoints, telling people why to use Zig, and I feel that it works. It works, especially when the creators of the language are actively out there. Cool. Enough of my rant. It's been a fun exercise. See you all in another video.